So when we think about these parametric word problems, we are going to talk about them here in terms of like what's happening horizontally and what's happening vertically. And so when we look at these examples, that's kind of why we're breaking it down that way, because we can define it in terms of x of t and y of t. So a couple key things. In this example, we're looking at a baseball, but we can map some information with a vector, right? And that's what is happening here is the baseball. If I look at my squiggly little arrow, the baseball doesn't fly like that. I just wanted to stand out a little bit. But it's flying like that. And we can talk about what's happening in terms of horizontal distance by using initial velocity times cosine. And then we can talk about vertical in terms of initial velocity and sine. And then we can write two equations. So these are two equations that we can do to take that velocity and apply it to, plug it into a formula so that we can keep going and determine more information. So this x equals, that is just distance equals rate times time, right? The velocity is a rate, distance equals rate times time. That's the formula we're going to use. The y one is a little bit more complicated because we have to also account for the fact that gravity pulls us down, which is in the y direction. And so that's why we use that projectile motion equation. Maybe you've seen it before, maybe you haven't. Notice we're using -16, which means we're just doing everything in feet per second. So that's just an important little wrinkle here. But those are the two equations we're going to use. And that's what I want to do now as we talk about Kevin. So here's our homeboy Kevin. He hits a baseball at 3 feet above the ground. In other words, that's our initial height. When he hits the ball, it's already 3 feet above the ground. It comes off the bat at an initial speed, and speed and velocity are similar enough where we can label speed with v aught for v initial of 150 at an angle of 18 degrees. Anytime we see angle, we got to think theta, because now we can speak. We are speakers of Greek with the horizontal. Will the ball clear a 20-foot wall? That's a height that we're wondering about. That's 400 feet away. That's an x distance that we're caring about. Okay, so our question is, what do we know about this baseball and its flight? And what we're going to do is we're going to use these formulas from up above. So the first thing we're going to do is we're going to start with, hey, let's make this into a vector. And let's talk about the two components of the speed. So in order to do that, we've got v aught cosine theta. That's going to tell us about the x component of the speed. In other words, how much of it is going in the horizontal direction. And then sine tells us how much of our speed accounts for vertical movement. So we had a 150 and then cosine 18. And then we had a 150 sine 18. And so now we can actually figure out what that is according to our calculator. And so I'm going to get into my calculator, and my calculator is kind of just chilling over here. Hopefully you can see it. We want to go, I'm going to go into degrees because that's what this question is asking. But I've got 150 cosine of 18 degrees. So in the horizontal direction, I've got, I've got something that disappeared. 142.66, we're going to say. So not all of the 150 is like horizontal. That would be like, let's say I had a cannon. And I shot the cannon at an angle of 0 degrees, and it was just straight out, straight in front of us. Then everything's happening horizontally. Here, because of this angle, some of it's horizontal, and now let's find the vertical component. So we have the ball moving horizontally and vertically all at the same time, all good things happening. I'm going to say 46.35. Okay, so that's an important thing, is to be able to break that down into its components. Now, we are going to work with the x equation and we're going to work with the y equation. I'm going to start with x and finish with y. And so the reason I'm going to start with x is because this question, sorry, my screen's a little jumpy. This question says, will the ball clear a 20-foot wall, right? That's what's happening. So my final answer is it going to do it or is it not going to do it? And that's when I'm going to know my problem is done. And so I want to know that when the ball is 400 feet away, am I high enough to clear the wall? So what I want to work with first is I want to work with this idea of 400 feet away. So let's dig into that. That's a horizontal distance. So let's look at our x equation. I know that I'm looking at 400 feet away. I know that the distance equals rate times time. So let's see if we can figure out t. It's the only variable in this equation. And so I'm going to take 400 and I'm going to divide it by 142.66. I missed a button, so I'm going to punch buttons again. Okay, so I've got about 2.8 seconds. In other words, the ball leaves the bat. It heads toward the outfield. It's zoom in, kind of. And 2.8 seconds later, it's gone the 400 feet that I care about. I know nothing about the height. I just know that from where I was standing, the ball is now 400 feet away in the horizontal distance. The question is how high up is it, and will it clear? Will it clear this kind of outfield wall that we're so concerned about? Oops, I wrote cosine, not cosine. That's a sine because we need sine for the y part. So there was our y equation. Okay. If we would have started with this y equation, we could have kind of done some things, but it's just a little bit trickier. X had just that one variable of time. We knew for sure that we had to get out to 400 feet. And so that we knew what the X was. So that was kind of why we picked that to start. But now I'm digging into Y. So I don't know what Y is going to be, but I know that T, right? This is T. This is T. T is 2.8. So how high is the ball 2.8 seconds later? So I'm going to plug in 2.8 and go from there. So I've got negative 16, 2.8 squared, plus 46.35, 2.8, plus 3. I've got 7.34, and since it's a distance, it's in terms of feet. I probably could have labeled this as seconds. 7.34 feet. So the moral of the story is this ball won't clear a 20-foot wall. It could actually be caught by an outfielder. Not that that's an important detail, but if this is my 20-foot wall, it's only about here. Here's where the ball is, at about 7 feet. And so a person who's standing there could probably put their arm up and catch it. Okay? I'm going to pause it here. I will go through one of the ones on the back. And so let's stay tuned.